This is a walkthrough of Problem 2 on Exam 1 of Module 5 in the book Problem Solving Guide for Mechanics and Thermodynamics. Problem 2 involves a toboggan with 4 riders at the top of a toboggan run in the Cleveland Metro Parks. The total mass of the rider and the toboggan is 300 kilograms. The total drop of the hill is a distance of 75 feet. The speed at the bottom of the hill is 45 miles an hour. Part A, in units of joules, what is the total work done by all the drag forces during the trip down the hill? Part B, after the toboggan gets down the hill, it travels on a level surface and comes to rest due to friction. If the length of the level section is 40 meters and the toboggan goes from 45 miles per hour to rest over this section, what is the combined work done by air drag and the frictional force? Part C, what is the total work done by all the forces on the toboggan from the very top of the hill to the point where friction brings the toboggan to rest? So we start with a good diagram. There's the tobogganers at the top of the hill. Let's label it. Total drop, 75 feet. V initial is 0. V final is 45 miles an hour. That's the speed as soon as it reaches the bottom of the hill. There are 2 ways to get the total work done. The first is to sum up the work done by all the forces, and the second is simply to get the change in kinetic energy. We know the initial speed, we know the final speed, we can get the change in kinetic energy. It's just 1/2 mv final squared minus 1/2 mv initial squared. Mv initial squared is 0, starts from rest. We have to convert the speed of 45 miles per hour to meters per second. So there's that conversion. The speed at the bottom is 20.1 meters per second, which is the same as 45 miles per hour, of course. And then we can calculate that the total work done by all the forces on the trip down the hill is 60,700 joules, which is the change in kinetic energy. This is the total work done. Now we can get how much work gravity did. mg delta y, the force of gravity, mg, times the distance moved in the direction of the force. We got to convert the units of the height from feet to meters. 75 feet is 22.86 meters. The work done by gravity during the drop, mg delta y, it's about 68,600 joules. So gravity made a deposit into the kinetic energy of the toboggan of 68,580, and it only has 60,700 at the bottom. It lost some due to drag. Something must have done minus 7,900 joules of work, and that something is the combination of the drag forces. The answer to part A is minus 7,900 joules, and if you've been on this run, you know that it's almost all air drag because that track is well iced, virtually frictionless. So on to part B. Here the toboggan starts at 45 miles per hour at the bottom of the hill and then eventually stops on a level surface. Let's draw that diagram. Reaches the bottom of the hill, stops eventually. The forces stopping it are air drag and kinetic friction between the toboggan and the track, and it's mostly the latter. They have some rugs down there, some carpets or something, and you really slow down fast. So to stop this toboggan, they have to take away all of the kinetic energy. The answer is the kinetic energy it has with a minus sign. So it's minus 60,700 joules. That's it. Now we do part C. What is the total work done by all the forces on the toboggan from the very top of the hill to the very bottom of the hill? Well, it's got to be 0, right? It starts at rest, it ends at rest. The total work done is 0. And that's part C, and that's problem 2.